Thank you, IROS, and I'm very happy to be here. Today, I'd like to talk about not on the research itself, rather the utilization way of the robot system, so the society. And especially, I'm introduce a Japanese activity of disaster response or infrastructure maintenance. The robot system are used. So my talk is, first one I will talk about so-called unmanned construction system. And also I'd like to talk about, I'd like to introduce the Japanese recent, actually this a few years activity of the maintenance or disaster response for the infrastructures. So I believe that important role of robot technology is for the society is provide a solution for the existing problem in the society. So recently, for example, recently in the industry, solution business is very active. And robotics is actually, it's one of the key technologies relating with the control mechanism or hardware and software as to give the solution for the problem. In this sense, in this context, the robotics is a way, research and development for providing solution, how to provide the solution is a main theme of the, it might be a main theme of robotics. So, especially in Japan, recent needs for the robot technology, especially for the infrastructures, is, first one is a disaster response capability. The photograph light up is actually water flood 2 weeks ago nearby my house. And this is first time of these 20 years of big rain. And we have many occurrences of the landslide, usually usually caused by the heavy rain. And also volcano eruption, and followed by mud flood. And also another need for the infrastructure is aging problem of not the human, but infrastructure itself. So recently, several bridges are very difficult to use, continue to use in Japan. And also, a few years ago, we have a very big accident of the ceiling of the tunnel dropped down and hit the cars. This is a graph of Japan of the years of the construction of the road bridges. And we can see from this graph, in the later half of 20th century, and many bridges are constructed, and they are now aging. And maybe in 2020, this graph is 2023, but maybe 2025, almost half of big Japanese bridges will take age older than 50. And the 50 years age of the construction is one of the point of we need serious maintenance. Also in the tunnel, we have such aging problems, similar aging problem. So I believe that the important keyword in the society now, it's not only, but anyway, the continuous keeping for the current comfortable life is important. For this purpose, the maintenance of infrastructures is very important. And if the infrastructure maintenance chain is cut, it is crisis to our daily life. And biggest problem, it is not so technically hard, but the problem is reduce the cost is the most important, because economy of Japan population and economy, population is now reducing and economy cannot grow so fast. And also to the disaster case, avoid the second disaster and to know the situation or start restoration is very important. So for this purpose, actually I believe that robot technology is very useful for society. And especially in the more concretely, practically, the two types of technology we have in robotics are very useful for this purpose. First one is access technology, the mobility. It's a mobility of the machine, but it should include not only the ground, but also the area, water, underwater, or wall climbing or something like that. And also, very useful technology for what we have is automatic operation or remote operation work. It might include many types of works. And as well, the robot technology can provide very important point to build up a total system, design and implementation for real use. This is also our strong point of robotics community. So actually for the robotic access technology is provide a possible of the maintenance system for a large structure without temporal scaffold. It might reduce the cost much. And actually we are developing robotics people, developing many methods of the access technologies. And as a remote operation for the disaster response, we have in Japan the remote controlled construction methodology named Unmanned construction. I will talk later. And also remote control, remote operation was very much used and effective, or we could do by remote operation in the case of Fukushima nuclear plant accident. It is still working in this field. So at first, I'd like to introduce something of unmanned construction system. This is really working robotic system for disaster response in Japan. It is teleoperated heavy machinery for construction. And teleoperation is to reduce the risk of second disaster or to make it work in a dangerous area. So this is a concept figure of the remote, unmanned construction. And the people are located in the room in a safe area, and communication is connected to the construction machine, heavy machines, and realize the construction works. And this is also the concept figure. And the construction machine works at where the people cannot be in, or it's better to avoid to come into this area because of the second accident. So, in this concept, in Japan already several works are going on. And usually machine operator uses images, several images from the several cameras on the construction site, and skilled operator, both skill in heavy construction machine control operation and also remote operation is work to control. So, the work, this figure, this image is after the big landslide in Kyoto Peninsula heavy rain. And actually it was very big landslide and big damage. Under the slide, there are several houses crafted. And still, many big amount of soils, rocks remained in the top of the slides. So, Ministry of Construction decided to remove the soils or other materials on the top of the landslide to avoid the second big slide. And this unmanned construction started at Unzen Fugendake active volcano in 90s. And we had a very big eruption, and heated debris flow made a very big damage. And after that, the mud flood by rain occurred, and many houses are covered by ash or debris rocks. So then we wish to remove the ashes and rocks, and also we planned to develop and construct a dam for as a debris barrier. But still, it was a very difficult, dangerous area. So we had to realize the construction work without human on the site. This was a Unzen project, and it started 1994, and actually it finished this March. And what kind of machine is used is like this: backhoe, bulldozer, or road roller, or many machines, dump truck, to bring the rocks and also to supply the concrete, and crawler dump as a water sprinkler, or many other machines. As well, the communication repeater is necessary, and the crawler dump is used for the remote controlled crawler dump is used for communication repeater, and also camera car is used, and a long arm backhoe was used for the camera. And okay, so this is our experience. And after Unzen, in Japan, we have applied this technology on 150 sites in Japan. Each is not so, some of them are not so big construction, but some of them takes 2 years, 3 years construction. And actually, this unmanned construction system is really practical system for real works and real site. And technology progressed much and improved while we are using this method in real site. And further, the total system established, which can be provided in the case of emergency. So actually in the case of Fukushima accident, we had a total system capable to bring to Fukushima. And one reason why we could do such methodology is actually we have often occurrence of the abnormal weather or natural disaster in Japan. It's abnormal but not so special. And this construction, for this purpose, this construction was ordered by MLIT, the Ministry of Land and Infrastructure and Transportation, Japanese government. And works were done as a business by construction companies. So this is actually a business application and really used for the Japanese society. And next, I'd like to add something about the recent, these 2 years activity between METI and MLIT. METI is the Ministry of Economy, Trading and Industry, and MLIT is the Ministry of Land, Infrastructure and Transportation. And this is development and utilization of the robot technology for infrastructures is the purpose of this collaboration. But focused much on utilization, not on the development or research. So, as Professor Takanishi told yesterday, at our opening ceremony, in Japan, Prime Minister Abe started so-called robot initiative. And robot initiative is much considering to utilize the robot technology for the society. Not much on the development or research. Actually, it's not so happy for us researcher, but anyway, focusing is a utilization. But for utilization, we need certain amount of the development, but more focused on the how to utilize. For this purpose, MLIT had a project evaluation and test use, and plan to use in a more real use. All this and 2 ministries agreed the scheme and decided and assigned 5 fields of robot expected to work. First one is the maintenance of structure on bridges, tunnels, and underwater structures. Second is the disaster response, especially investigation and restoration. And based on this scheme, NEDO, it's a funding agency of Ministry of Economy and Trading Industry, started a project for development of system to solve the social problem as infrastructure maintenance. And it includes not only the robotic system, but also including sensing technology or imaging technologies. And actually, I myself is appointed to be a project leader just to manage of this project. And for the robot system, several access technology are really under developing, but each development is seriously considering the real problem or real site, real needs. And terrain mobility or wall sailing mobility or special methodology using rail to test the bridges or underwater testing equipment, and also other access methodology, UAV is very much used. And based on this scheme, Ministry of Land, Infrastructure, Transportation called the public offer for the robot technology to be used. This is not support of the development, just call the possible technology. And this ministry test and verification of usability and evaluation and find the possible robot system for test use, and after test use, they are planning to use in more real purpose. And in last year, many robotic systems are applied from many companies or organization or university. The total number in Japan was 143. And it's bridges, tunnel, many kind of the robotic or automatic technology are used, including vision system, but not element technology, rather just technology can be applied for this problem as a system is applied. And underwater maintenance and disaster investigation and restoration. And this is images of the evaluation test, and at the real site, using real bridges or bridges. And this year, we are planning to use more realistic bridges, which is more old and have many problems. And as a tunnel and underwaters. So maybe each machine took 1 day or 2 days to be tested. And committee based on the Ministry of Land seriously check the function and it is useful or it is possible to utilize or not. And so actually some of them are already well known and technology, and some of them are not known technology, but it's very difficult to make it secret because we test it in the open area. So many technologies were observed by many people. Okay, this is just an introduction of Japanese activity for infrastructure maintenance and infrastructure disaster response. And one point of this unmanned construction system is, anyway, it is utilized the first, rather. When we started, we had construction machine and communication, camera, monitors, everything. So then we started to just connect to use. But after that, we know many problems to make more effective work or more wide range work. So then technology is advanced very much by using this methodology in a real purpose. As well, activity of infrastructure maintenance and disaster response is also importance is the utilization and the social implementation of the robotic system. And this is rather big challenge of ours to use the robot technology in the society. Thank you very much.
Thank you very much. Are there questions for Professor Yuta? Well, I mean, one obvious question is, you mentioned that the problems are not in technology, but in cost. So, right, that's what you said. So, do you see any potential for cutting costs? I mean, if you look at these big machines, they look like standard construction machines, and I don't really see where you can make them cheaper. But maybe there's some potential for rationalization here. Maybe you can elaborate a little bit on this.
Yeah. The most cost problem is the human labor. And especially when we use the human labor in a very dangerous place, we need some special scaffold or many other structures. Mm-hmm. So, but for example, recent UAV can very easily bring the camera or other sensors to the site. And maybe use, for example, such a robotic system, cut the cost very much. And the other side, problem is, this is, even though the work is, we have a tremendous big market of work, but number is not so high like a smartphone. So then the cost, reducing the cost of the machine by mass production is rather difficult. But still, we think that, for example, when the diver, we hire the diver to observe the very deep water on the dam. So for the investigation, we need more than 1 million yen a day for the diver cost. But so maybe we need 2 people for 5 days. Then 10 million yen cost for the investigation. But using underwater vehicle, we can reduce the cost much. But at this moment, no commercially available underwater vehicle can be used, cannot replace the human diver at this moment.
Yeah. But I mean, we saw Usama's presentation yesterday. Maybe that can also be helpful here. Okay, since we are already running late, I thank you very much again.